So we're going to talk about different kinds of bivariate relationships, and specifically today we're going to talk about contingency tables and which uh, kind of variables are used in contingency tables, or for which kinds of variables contingency tables are most appropriate. So a little bit of background on different kinds of bivariate relationships. With bivariate relationships, we're looking at the relationship between two variables, right? So we're interested in seeing the patterns of relationships in terms of the categories of values of one variable and how it lines up with the categories or values of the second variable. More specifically, we're interested in learning how changes in the attributes or categories of one variable affect those changes in the categories or attributes of that second variable. Um, and we want to know if two variables are associated. And if they are, we can use some kind of score for one case, predict the score on the outcome variable or on the other variable. These two types of variables, as I've mentioned in previous presentations, are known as the dependent and the independent variable. For bivariate relationships, when we're looking at the relationship between two variables, we're interested in not only the direction or pattern of the relationship, but the strength of that relationship. So is it a strong relationship or a weak relationship? Um, in certain kinds of bivariate relationships, that idea of strength is easier to tackle or understand. For instance, if we're using a correlation or a regression kind of format, um, we can understand the strength, not just the direction. With these bivariate relationships, we need to undergo statistical significance tests of these relationships to understand whether or not these relationships are occurring by chance or they're relationships or associations that are, unique or extreme, uh, and something that we would see in that population. So again, we have independent versus dependent variables. Independent is our X variable or predictor, or dependent is our Y variable or our outcome. So we have different kinds of bivariate pairs. I don't include one of them because there's a special kind of test for uh, something else, and we could talk about that later. But we have three that I want to focus on. We have an independent variable that's categorical, so nominal or ordinal. And then we have a dependent variable that's nominal or ordinal. For example, we have level of the education broken down by, high school, um, or GED, less than high school. We have some college. We have college graduate. We have graduate school. We have professional, right? And we have something for a dependent variable called SES. So, you know, upper middle class, we have middle class, we have working class or low SES. And these are two ordinal kinds of variables, right? Education goes up with these various levels, SES from high, middle to low, or upper middle, middle, working, that goes from high to low. Another kind of bivariate relationship pair is a categorical independent variable and a continuous dependent variable. So nominal, ordinal, independent variable, interval ratio, dependent variable. So for example, we're looking at the same thing of level of education. So some high school graduate, some college, college graduate, graduate school, professional school, doctorate degree, an ordinal variable. And we have our dependent variable, which is income. So annual dollar amount of income. So $0 to millions of dollars. And then we have a third kind of relationship where both the independent and the dependent variable are continuous, meaning they're both interval ratio. So let's say we're looking at the relationship between experience or number of years of experience on the job and income, so the annual dollar amount. So these three kinds of bivariate pairs would necessitate different kinds of data visualizations and different kinds of analyses. Here we have these same types broken out. So categorical independent variable, so nominal or ordinal, categorical dependent variable, so nominal or ordinal. We would use contingency tables, right? And that would say, what are the categories of the X variable and what are the categories of the dependent variable? Um, and that's just going to be a cross tabulation. For this next one, we have an independent variable that is categorical or nominal or ordinal. And then we have a dependent variable that is interval ratio, so continuous. Here we would be comparing the means. So one group of the independent variable, what is the mean for that group? One group uh, of the next group of the independent variable, what is the mean for that group? The next group for the independent variable, what is the mean for that group? It's a relationship between a categorical independent and a continuous dependent. So we'd be comparing the means of a continuous variable across different groups of the categorical independent variable. We would use something like, we don't talk about this in this class, but we'd be looking at different kinds of bar charts, looking at the means for each of them, and we'd use something like a t-test or an ANOVA as a specific kind of statistical test. And then finally, we have an interval ratio independent variable and an interval ratio dependent variable. There, we would use something like correlation or simple regression, where we're looking at the relationship between two interval ratio variables. We would use something like a scatter plot to demonstrate the relationship there. So if we're looking specifically at the relationship between two categorical variables, we want to display the values or categories of these variables in a matrix or a table, right? These tables are known as contingency tables or cross tabulations, crosstabs. So for instance, we have this example of college major and job type or actual job. So we have a breakdown for each of these cases. Here's a snippet of the data set on the left. We have a bunch of different cases, and for the job, we're simply specifying is somebody a social worker or are they not a social worker? And then we want to ask, was their college major in social work or was it not in social work? So we have a yes, no on social worker and a yes, no on whether their college major was social work. And we can take this information and create a cross tabulation. So we can say the number of people who were social workers, 40, and the number of people who weren't social workers, 60. And of those same 100 people, what was their college major? Social work was 55, not social work was 45. So we can take all of that information from these two frequency tables and create a cross tabulation or a contingency table where it's lining up the values of job by the values of college major. So we say we have 30 people who were a college major in social work who actually work in social as a social worker. We have 25 who were in social work as a college major but aren't working as social work. So 5 fewer people are working in social work. Next, we have people who didn't have a social work major working as a social worker currently, and that's 10 people. And then we have 35 people who weren't in social work and they're still not working in their job as a social worker. The contingency table breaks down how many people are social workers, 40, how many aren't, 60, but also how many didn't have social work as a college major and how many did, right? So these, we have totals on the bottom row here and total on end column here. These numbers, so 40 total social work, so current social workers and 60 total not social workers, those are known as our row marginals, basically the total for the row. And then we have column marginals, which are the total for the column. So 55 people said they didn't have a social work major, and 45 said, sorry, they did have a social work major, and 45 said that they didn't have a social work major, they were in something else. Next, we can take this information and we can standardize across our independent variable of college major to compare the people in these different majors, right? So we say there are 45 people, for instance, there are 45 people who didn't have a social work degree. 22% of them, so 10 out of 45, that's 22% of them are working as social workers. 78% are not working as social workers. So most of the people who didn't have a social work major, 78% of them are not working as social workers. Next, we see for those in social work, so we have 55 total, 30 of the 55, so 55% are working in social work, and 25 of the 55 are not working in social work. So 55% of social work majors went into social work. You can see here, 78% of those who didn't have a social work major are also not working in social work. So this is important to note. So I say here that social work students are more likely to be employed as a social worker. So 55% of social work students um, uh, in the sample were working as social workers, compared to 22% of those who weren't in social work working as a social worker. We can also see that 78% of those who didn't go into social work were actually not working in social work. So standardizing has to do with just creating percentages. Here we standardized across our independent variable of college major. So we're saying, what is the total for college major? So 45 is the total for other, 55 is the total for social work. So we're saying 30 over 55 is 55%. 25 over 55 is 45%. Same thing for other. 10 over 45 is 22%. 35 over 45 is 78%. We can also standardize by job type, right? So we would say 30 over 40, right, come from social work. 25 out of 60 who aren't social workers come from social work, so on and so forth. So it's important to know what you're standardizing by. And here we're doing just that, right? We're standardizing by the dependent variable of job. So we see here that social workers tend to most likely have social work degrees. So 75% of social workers, so 30 out of 40, 75% come from social work, okay? Compared to 25% of social workers getting the degrees in other majors. So 25% of social workers come from other degrees, right? So we're standardizing across the rows of job. And finally, we have this additional example. We can standardize across an independent variable of political ideology to compare people of different political stances. So we have this variable called opinion on death penalty. So do people favor or oppose the death penalty? And we see that we're standardizing across our columns because we have 100% here. 55% of liberals favor the death penalty, whereas 44.6 oppose. So that might seem high, right? We might tend to think that liberals are typically against the death penalty. And here we see that the majority are still for the death penalty. However, when we look across different categories of political ideology, we see that that number is much larger for more conservative ideologies, whereas 55% of liberals favor the death penalty, 70% of moderates favor, and 75% of conservatives tend to favor, right? So the percent of favor goes down as political ideology tends to get more conservative.